What an awesome conference this is. Shall we get started? Yeah. So, I'm really excited to be here. Great conference. In this upcoming talk, I will explain an architectural pattern that I've used for 2 reactive applications and that I've also written about extensively on my blog. But first, let me tell you how this came about. So there's a theory that it all started with a Big Bang. Then a couple billion years later, my father somehow met my mother. Another couple of decades later, I submitted this talk. Okay, that's the really short version. But let me explain a little more about the motivation. First, I have a question for you, though. How many of you know what a potluck is? Good, a few. Let me explain. Oh, people are still coming. Come on in. So, a potluck is a social gathering where people, the participants, bring food. Everyone only brings a single dish, with the one unwritten rule that you bring something that is large enough to share. This kind of gathering is particularly common in the US, for example, after religious services, and I've attended quite a few when I was in the US. And there was one thing that I always wondered about, and that is that there was always such an abundance of food that nobody could possibly eat. So the question for me was, why do people bring food? Pretty much everyone brings food. Now, game theory in its most naive form would suggest that you don't do that. You would just trust that others bring something. And you would be right. Of course, if everyone followed that logic, then nothing would be there to eat, but that's not going to happen. So why do people bring food? And I'm talking beyond this guilt-driven thing of like, I have to participate something, I have to bring something because otherwise the system would fall apart, because likely it would not. Not everyone is a free rider. There's always going to be something. So one time, I had a conversation with the organizer of such an event. And I asked her, because I was really curious why that was. And her response was interesting. She said that food just happens to be a great conversation starter. It gives you something to talk about that is much better than the weather. The thing is, so you're at this gathering, and people will ask you. They will ask you, what did you bring to the table? What are you going to say? You could find a white lie and say, oh, I didn't have time. Or you could tell her that, well, game theory suggests that it would be irrational, and I'd be much better off if I eat your food. There goes your chance to make a new friend and a good impression. Or you could tell her that you made that delicious tomato salad that everyone was talking about. I really like to make this tomato salad, and it's really good. So this is the incentive. You get something to talk about, and maybe you're even in for that warm and fuzzy feeling that praise can give you. If you don't bring anything, you're simply missing out. But why am I telling you all this? Isn't this supposed to be a software conference? I noticed maybe 2 years ago that open source is not all that different. Well, you could argue that there's a moral obligation to contribute something because the whole system can only work if everyone contributes. But that is not true, even less so than with the potluck, because at the potluck, at some point the cake is gone. Software, on the other hand, doesn't wear out. You can copy it a million times, and the original, whatever that even means, with a distributed version control system, is still going to be immaculate. But you have the same kind of benefit, potentially. And that is you get something to talk about, and you also might be in for praise. And we all know that that feels good. So today I can say all this for sure. But until last year in March, that was only a dream. And it was a dream that I did not put into effect simply because I was scared. I was afraid of being in the spotlight, of messing up, of writing nonsense, and of talking nonsense for everyone to see. But at the same time, I wasn't happy with what I could show for my work. So I thought, well, I need something to show. Just like an artist has a portfolio of previous work that he or she can show, I wanted something to show as well. So I've been interested in data in motion, roughly speaking, and I thought, well, Twitter would be a good data source. That came up pretty soon, the Twitter streaming API. So I started working on this application to have something to show, because before I had mostly been working on projects where I could not talk about or definitely not show any code, and the clients would have definitely not allowed that. So I wrote a first version of that application, and with Play Framework, and that was surprisingly fast. I had the first running version within a day. This is roughly how it looked like after a week or so. And then I happened to be in Amsterdam over a long weekend, and I found this, yeah, I know it's Rotterdam here. I found this meetup in Rotterdam about Play Framework. So I went. So this guy, James Ward, some of you might have heard of him, was speaking there. And him and Nicolas Leroux were presenting Play Framework, and Roland Kuhn were presenting Akka. The talks were really great and got me hooked on the type-safe stack even more. But the best part was after that, after the talks, I got to talk to James and showed him my first project, my first open source project that I just had started working on, and told him that I was considering starting a blog. And he was super encouraging. He told me that it was a really neat start and I should definitely go ahead with a blog and that I'd be great at it. And I don't think I would have even started without that encouragement at that time. So I'm really thankful for that. Then I posted an introductory article shortly after, like 2 weeks later or so, and if I counted correctly, 16 more articles since. So let's go for the geeky part. That's the applications that I've worked on since then. The first one, and by far the most popular one, is BirdWatch. Some of you might have seen it before or used it, also for the conference maybe, because you can search for tweets. It's an application that consumes the Twitter streaming API for a number of terms, and then you can search it. And actually, let's have a look. How many of you are on Wi-Fi right here? Can you tweet something about the conference with the hashtag Scala Days? Just say how great the conference is or something, how well it's organized or so? Because that should show up within a second. Ah, there it is. That's more. Awesome. Glad that worked. Thank you. So, that. I don't need that anymore. So we're going to be talking about the architecture of this application, and then also another application that I started last year during Scala Days in New York, and that was a chat application, this other application. Well, the world surely needs another chat application, and that seems to be the canonical example for interaction and bidirectional communication with a server side. However, this one has a twist. And the twist here is that the chat rooms, there are 5 chat rooms, they work as expected, but in chat room 1, there are also Romeo and Julia hanging out. You know, the ones from Shakespeare. So why do they do that? Well, I was thinking about the experience when you try out the application, and hardly anything is as boring as chatting with yourself in a chat application. I really don't need technology when I want to talk to myself. So there are different clients for both the chat application and for the BirdWatch application, and we definitely don't have time to go into detail on the client side here. Then we could talk for hours, but there are a couple of articles, and I will post the links later on. What we will talk about now is the information flow between the client and server. So there's a two-way communication between client and server by using server-sent events. Server-sent events are a candidate for a standard for a chunked communication or for a chunked connection between client and server, where the server keeps pushing data to the client. The connection, the HTTP connection, stays open, and whenever there is data available, another chunk of information will be put on that connection. And then what I'm using for the other direction here in these applications is simple REST API calls. So how do these look like? That should be playing. Let's take the last one. Okay, so this is from the chat application, and this is the JSON representation of the data whenever a new message is there. These messages here come from actors in the system, the Romeo and Julia actors, but I could also say something here, and it should show up as well. Whoops, whatever. And yeah, it's connected to the same thing. We should see my message there as well. So what is to note there is this data. There can be different kinds of messages with server-sent events, and the standard is to call it data, but you can call it different names. And then on the client side, you can discriminate between different kinds of messages if you have multiple ones. Okay. So how does Play Framework deal with providing a stream of information? So there are reactive streams in the works. Some of you might have seen that talk earlier. But what has been around for longer is the iterati library for providing these kinds of streams. You could also go with actors, go more low level, which would also be interesting. But the iterati library in these cases provided a really simple way of dealing with that. So what is that iterati thing? No, it's actually not that, just a cute photo I found. But it's when looking for this one here. So we can think of the iterati library consists of 3 main parts. And that is the enumerator, which is the source of information. That's the faucet. Then we have 1 or 0 or multiple enumeratis. And the enumeratis are transformers or filters of information. This one is a pretty good way to depict that. And then finally there's the sink or whatever where that flows, where the water flows here. That's the iterati that consumes that. You could also think about an iterati as a fancy fold, because you can accumulate information and do computation and ongoing computation, not infinite, but for a while, over data that does not exist yet. And there's a lot to iteratis that you can do with them, but I really only for these applications need a small part of that. What you should do if you want to learn more, you should check out James Roper's excellent article on iteratis. In these applications, I really only need one, and that's a simple for each iterati, what I do with each chunk of information. Or actually, when it comes to server-sent event streams, I don't see that final step at all. The information is just passed through a couple of enumeratis and then given to the feed, to the OK.feed. And then there's another building block, the so-called concurrent broadcast. Concurrent broadcast is an object that gives us the ability to create a channel and an enumerator. It gives back this tuple of a channel and an enumerator, and the channel you can push information in. And then you get an enumerator that you can use in multiple places in your application that you can attach enumeratis to, and then finally an iterati, and have the information flow through. We will see that in code, but just to introduce these concepts. So. Actually, let's start with the other one first. That one's simpler. So here, this is the concurrent broadcast that gives me this tuple. And I call the channel chat out here, the chat channel, and then the chat out is the enumerator. And that is of type JS value. Then I can use this to post messages. This is a play endpoint here that I use, and I take the request and push the body of that request, which is a message, this hi with my name attached as JSON, onto that channel. Or in this application for chat room number 1, it's actors doing the same thing. They also use that channel and push messages onto that channel. And then I have the chat feed, which is another endpoint. And this endpoint serves this chunked, long-lived connection to the client, which we've seen earlier. So here I have the request, and then I return this OK.feed. And for that, I use the enumerator that I've been talking about. Then a filter, because I only want to pass on the messages that are in the same room, and that's what I use the request for. Then I use a buffer. And then here, what I called connection death watch, just to print out something when the connection is disconnected. And then finally, I pass that to event source, which allows me to build this server-sent event stream. And that's really all there is on the server side for the chat application. Well, there's this actor as well. Let's have a look at that quickly. So here, I have a supervisor that schedules messages to be sent every now and then, every 5 seconds. And then I have this actor, and this actor, when it receives this case object that it should quote something, then it just takes one out of one random string out of this sequence down here, and then just pushes that onto the channel, just like the endpoint in chatapplication.scala. The BirdWatch thing is slightly more involved, but really not by a lot. Here, again, I have this feed with the query. In this case, I use the query to build this query JSON object, which I then use for Elasticsearch. And for this feed, I'm using what is called a percolation query. Who of you knows what a percolation query is? Okay, that's very few. So a percolation query is kind of a reverse query. You store the query string, or the query as such, in a collection in Elasticsearch, and then later on, you have new items that you want to store somewhere in an index. And then you match the new item against existing queries. So it's a query upside down or reverse or whatever you want to call it. And since I know the query and I use a hash of the query, I know the ID of that query. That's what I use as the document ID in Elasticsearch. And that's also what I use in the filter for the feed. So that way, Elasticsearch gives me back that ID, and that's deterministic. I can always hash the same thing and will derive or will get the same ID. And then I filter that by this query ID. So all the tweets come in here in this out of this enumerator. And then I do this filter, this match by query ID. Same thing, buffer. Then I convert the case class to JSON. And then finally, I push it onto that streaming connection. Here I also have a client to the Twitter streaming API. And the Twitter streaming API is not all that different from the event source connection. There's no prefix. That's pretty much it. Other than that, it's a chunked HTTP connection where in an ideal world, every single time or every single chunk of information would have one tweet in it. That was the case for a long time until about March. Then that changed for no good reason, but that's how it should be. So here, I have this tweet iterati that I attach to this streaming connection. And with this one, I'm doing a for each and just specify what I will do with every array of bytes that comes in. And then all I do here, it's a little complicated now because of the possibility of not always having a complete one, a complete tweet in it. But what I do is I just pass that and then send or push every tweet onto this enumerator. Oh, there we go. And this is the architecture of that application. So here the tweet comes in through this open HTTP connection, then it's processed by this WS client here. It's put on, or it's used by this tweet iterati, which both stores it into Elasticsearch and also finds the searches or queries that exist in that percolation index. And then here I have this tuple of the tweet channel and the tweet enumerator provided by concurrent broadcast, and then I attach that stream. Oh, I did explain that already, and I've shown you the code. Okay, so why am I using this and not WebSockets? Because WebSockets would seem like an obvious choice for communication that goes both ways. But the problem with WebSockets can be, well, first of all, there are a lot of incompatibilities, and I think there are, I don't know, 12, 15 different standards that are all not compatible with each other. And also, I have a different connection type. Servers and events is just plain HTTP. Every single firewall out there knows how to deal with that. That might not be the case with WebSockets. I don't have much experience with WebSockets, but I just find servers and events conceptually so simple because, yeah, the network infrastructure has been dealing with long-lived connections for a while. Just download something large and that could take an hour and it's a long-lived connection. When would I use WebSockets though? I would definitely use WebSockets when, and go or put more effort into that, when I had a lot more information going from the client to the server. Because here, every single time I have to transmit something from client to server, I open a new, or start a new REST API call. Which is fine if you do that once a second or every 10 seconds, or how often do you chat? Like, you can't do that 50 times per second. When you wanted to do like a collaborative drawing application, for example, where you have to capture the mouse moves and have to project them on another screen somewhere else, then I would definitely use WebSockets. Also with WebSockets, the messages are guaranteed to be in order because they are pushed through the same connection. Whereas REST API calls, you don't really know how long they take and which one will arrive first. There might be a problem or caveat potentially though, and that is support for Internet Explorer. Microsoft, for whatever reason, does not like this event source object. I don't understand it because it's very, very simple. But luckily, there's a polyfill for that that works fine with Internet Explorer 10 and 11. Supposedly, this polyfill should also work with versions below that, but not even Google is supporting IE 9 anymore, so I'm okay with that. But yeah, I just wrote an article about that recently, and if anyone wants to contribute and play with Internet Explorer, yeah, probably not. Okay, so let me summarize the technical part. So we're dealing with a two-way communication with a long-lived HTTP connection using the server-send event standard and REST API calls for the back channel. Not all applications could be built this way, but for the applications I've been working on, this provides a really nice and simple and conceptually simple way of building such an application. There are multiple clients for these applications, and I will tweet links to those articles later for anyone who's interested, because we cannot definitely not deal with any of that today. I also had a chance to explain to you why I started writing these applications in the first place. I'm thankful that someone encouraged me a year ago, and I would like to do the same for anyone here in the audience who thinks, hey, I would want to do something, but I just find a myriad of reasons not to. Because it's really rewarding. I really like it. I was definitely thinking the same thing, and I was terribly afraid of exposing myself. Your fears are real, but nothing ventured, nothing gained. I just recently saw this. Does anyone know this commencement speech by Steve Jobs from 2005? Yeah, it's a really great speech. I just saw that recently, and this quote, he also used that there, "Stay hungry, stay foolish," from the whole Earth catalog. It's pretty cool. So, my open source contributions might not be as good as my tomato salad just yet, but I'm working on it, and I have plenty of fun in the process. And I've also open sourced my tomato salad. It's out on GitHub. And just add your recipes as well if you like. Yeah, and if this talk inspires anyone here in the audience to overcome any of those reasons to get out there and do something, then I will consider this talk a success. Thank you. Questions? Yep.
but the API is so complex, or you find that it's
Which API?
API to stream with iteraties and so on.
Well, there's a...
Sorry, with broadcast,
Yeah.
unicast and so on.
Yeah, so there's a lot more in the iterati library than I find I need. And there are a couple of really simple ways of building something like that, but there's a lot more, and you probably don't need all of that. I tried to read the source code of the whole library when I started with these projects, and then first I was thinking, oh my God, I will never be able to get my head around that or wrap my head around this. But then after just picking the small parts that I needed, it was okay. Yeah, definitely. Yeah, that's one of the next steps that I'm thinking about. But last year there was nothing like that yet. Yeah. Okay. Thank you. Okay. Yeah.
About maintaining this thing.
Yeah.
I mean, it's this thing that you start something and then you have to maintain it for the rest of your life.
Yeah.
And that can be a thing that you have so many things that you maintain that you have nothing else that you can do anymore.
That's true, and without this warm and fuzzy feeling that stars on GitHub might give you, I probably would not have continued working on these. But yeah, and there's always something to do and changes to make and a new version of Play to adopt and stuff like that. But really, the bulk of the work had been in the beginning. Now maintaining it is not so bad. Except for when Twitter changed the behavior of the stream, that was pretty annoying. Yeah. That's a really good point, and in these applications, none. That's something that I always wanted to do for another article, and I probably will, but so far I didn't get around to that. Yeah, thank you.
So what's next on your agenda? Are you going to build a third application with different technologies? Or kind of sad right now that you're going to testing these applications and why not that?
Well, one of the things I wanted to do next is a little different, and that is building a developer cluster using Docker, so that you can test this whole thing on one machine with like multiple instances of Elasticsearch, multiple instances of Play, load balance the whole thing with Nginx or whatnot. So that's one of the things that I have in the works, and probably other applications like this. But yeah. Yeah, there are different ways of approaching that, and what I've done so far is really just load those files as directly as a dependency, and yeah, there's a lot of improvement that could be done there. It's also one of the things that should become an article using SPT Web there for the build system for the application, but that's definitely not as refined yet as it could be. For BirdWatch, there's, with the React.js version of the client, I have a Grunt-based build system that works fairly well, but the Angular version, yeah, I never got around to that so far. Yeah?
There's one more advantage. GitHub is an excellent backup.
That's true. Definitely, yeah. Any questions about the clients, if you're curious about any of that? Okay. Thank you.